So we're good across the board. And we try to not just teach you about HDPE, we try to teach you about the overall systems, because Lord knows it's hard to really get out there and proactively rehabilitate infrastructure. We've got a big problem looming with lots of work to be done. So there's only so much that you've got time for continuing education, and we're glad that you spend it with us. One of the things I'd like to add on the upcoming ASCE UESI conference in Indianapolis is an absolute dedicated workshop, a 4-hour workshop on all things high density polyethylene on the Sunday predating the conference there itself. So Sunday, July 31st, then the conference will kick off formally on the very next day on Monday and continue through there. So if you are in the area and you want to spend 4 hours on a Sunday afternoon with us, that's where we're going to be, and we love to talk about HDPE, and we'll be talking about HDPE quite a bit for you there. So any questions that you have that are just burning in there that don't get answered today, we'll bring you a lot of good material on that day as well. So without further ado, instead of taking the 101 route where we teach you everything about high density polyethylene, its origins, and how it comes to this at a molecular level, we're going to try to boil this down real quick for you. So it is a thermoplastic, and what that means is you can cut it, refuse it, cut it, refuse it, cut it, refuse it, cut it, refuse it. That joint is as strong, if not stronger, than the actual pipe material, and you could do that into perpetuity. You do not damage this pipe material as we go through. So you know that old adage, measure twice, cut once. We definitely can do that in this scenario. And if you don't follow that, or you didn't take your measurements right, then you can cut that again and refuse that pipe as many times as you want to do that there. So it does retain all those physical properties, and we have lots of diagnosed proof and lots of good tests for you to do in the field as well. So that way you can follow up, make sure your people are fusing it properly. And a semi-crystalline polymer, what this is very important for us because it's evolution in the generation of resins. So now we have a main chain as it goes through, and we are putting in an amorphous region as well as that semi-crystalline region. And what that really will do for us is it'll give us a higher density, which allows us to be able to have that longer life and higher pressure resistance as we go through internal pressure resistance. And then we also have that increased fatigue resistance, and then also increased slow crack growth resistance. So this product continues to change and develop and evolve into something better as well. So what we're doing through the fusion process, and this is the same with virgin raw HDPE material, no matter what way that you fuse it, whether or not it's extrusion at the factory, or it's butt fusion, or it's electrofusion, sidewall fusion, what have you. We're getting back to that virgin material by scraping, by cleaning, by doing those things to make sure we do not have contaminants. And then we are controlling the environment as to which it's heated and pressurized to be able to push up against. So all of that raw material can run directly across the board, that interface, and give us that joint that is as strong, if not stronger, than the original pipe material. One thing I'd like to show in this bottom right picture is this is a product Richard's company does make it, and lots of other companies make it too, but it has a white interior surface that is co-extruded with the actual pipe material, so it's no different. All they're doing is changing the pigment on the inside of the pipe material in order to be able to show the CCTV camera light better. So that's very specific to a development to gravity sewer inspection, because we know we need to inspect and clean that pipe as we go through. Pete, yes, please share.
Yeah, so that product is called Camcore, and you can ask for that by name. But Alan, so there's that, but there's also gray pipe. So gray pipe doesn't have the black master batch in it, but it's what a lot of cities are using for sewer work. Like Houston, they're doing 80,000 lineal feet a month, and it's all gray pipe.
They know that they're going to get it in the ground, and they know that they need to fast, and then they're making that happen right there. So yes, it doesn't have the UV block of black pipe as it goes through, but you do have a time period as to which it will not be denigrated above. So here's some more examples for you that joint is as strong, if not stronger, than the pipe itself. Here's what Pete likes to say is that double rollback bead that we're getting right into that Camcor pipe as you see it. This is no different than all of the other thermoplastic confusion videos that we showed you. And again, I'd like to further reinforce that once we get back to that virgin high density polyethylene material and we control the manner as to which it runs across to the other high density polyethylene material, and we have a fusion zone that is as strong, if not stronger, than the pipe itself, no matter which way that you fuse that product. So in the development of the 4th generation and better or evolvement of high density polyethylene, a significant amount of time was done studying targeted failure mechanisms of municipal pipes. So we're looking at solving for corrosion, soil displacement, and fatigue resistance. So one of the specific things for gravity sewer is soil displacement, as you can see from this vitrified clay pipe that we're looking at in the bottom left. A lot of soil materials already in this. That joint will separate, and then we'll get intrusion of the soil, which eventually leads to collapse of the pavement that's on top of it. Manholes also are a major point of soil displacement. And in fact, that 5 feet outside of that manhole sometimes is going to be one of those areas that gives us the largest frequencies of breaks and separation with our gravity sewer system. So HDPE solves for that because we don't have joints that allow that, that dirt and other soil material in through it. And same thing for roots. The roots are looking for material to be able to support itself, all that moisture, all that water that it's looking for. We've also solved for construction installation failures. Pete, can you come on and tell me what's going on with this PVC pipe on this side here in this right picture? This is one of the most common failures for construction of PVC pipe. And what are we looking at?
Sure. So Alan, we've been helping Flint, training Flint on polyethylene. It's been a long process to get to that point, but this was a 2020 installation of about 2 miles of 16-inch PVC that Alan suffered during installation, where the contractor over-inserted the spigot in the bells and broke well over like 2,000 feet of the pipe in succession. So Flint had trouble with this 16-inch water installation because of over-insertion. PVC is no different than us, Alan, in the respect that you got to do it right. In our case, you got to fuse it correctly. In their case, you can't over-insert it and you have to treat it. It is a brittle pipe, so you have to treat it a little bit more gingerly. But we all have our own issues. In this case, this really troubled the people in Flint.
Thank you very much. What you'll see with just the skill saw here on the left, as well as an easy workability, chainsaws without oil are another way to be able to handle this pipe. Again, you can cut that and refuse it, cut it and refuse it, cut it and refuse it anytime you need to about that. Pete, come on, tell us a little bit about this $65 million sewer project in Fort Lauderdale. I put this early in the deck, Pete, because essentially it is a display of lots of techniques we're going to cover. So I want everybody out there in webinar world here to be able to think about it. But essentially, they had force main failure underneath the major water body that was a marina, and complete failure of that pipeline that they couldn't even do a simple repair. And every day, many pump trucks that have a capacity of only 2,000 gallons thereabout from my history of vac trucks and having to order those on sites as well for failure, had to run consistently, which is a fairly big problem.
So this is one of the largest mobilizations that I know of, Alan, in the polyethylene world. The engineering staff of Fort Lauderdale showed up at a live road show that I hosted in Sunrise, Florida. Brian Fletcher, just a wealth of knowledge down in Florida with ISCO Industries, was my co-host. And they learned about polyethylene. And then within like 9 months, Alan, they had a major failure underneath the intercoastal waterway of a force main, kind of low pressure force main, but still it was dumping millions of gallons of sewage into the intercoastal. And then subsequent to that, they had another failure, and they realized that their force mains were all failing similarly under low pressure, under bodies of water. So they learned about polyethylene, starting with the Alliance. Then Brian Fletcher at ISCO got in there and worked with them very closely to educate them. Then they hired Murphy Pipelines on a emergency basis, Alan, to initiate half of the project. And they hired another contractor as well. And they did many miles of horizontal directional drilling, very little open cut. So they solved the problem inside of about 24 months with polyethylene, not slip lining, not bursting, but running new lines parallel for the most part. And they were getting, as you said, vac trucks in there, hundreds of them weekly, major fines from the EPA. Polyethylene came in, saved the day, but it did take some time, Alan.
That, of course, is the worst case scenario. We never like to see that. We like to see proactive rehabilitation, and sometimes you're not afforded that opportunity, but lots of different methods employed on this project. And as we go through, continue to think about how polyethylene comes in and helps save some of these areas as well. So
one
yes,
other thing I'd like to mention is that, these were not 24-inch diameter projects. These were 48 and 54-inch diameter DR17 polyethylene, large diameter, big fusions, big pulls, very large machinery. But Alan, it was mostly done without open cut. And they call it trenchless, but you and I both know it really isn't trenchless. It's just less trench.
That's correct. And the way that we construct force mains, water mains, new pipelines underneath river crossings are slightly differently than they were done 40, 50 plus years ago as well. So we have less and less opportunity to be able to impede that water body, and more people are turning towards large horizontal directional drills for large pipelines. So this is the general agenda of what we're going to be covering today. We're trying to get through as much as possible. Lots of good information for you, not just on polyethylene, but about installation, maintenance, and operation of sewer systems itself. So gravity sewer main lines are typically not pressurized. When we do trenchless, such as pipe bursting or other slip lining applications or other things of that nature, we are typically looking at a DR17 pipe, and what we're resisting there is that tensile force. So that large diameter, even though it's a low flow force main that we were talking about with horizontal directional drill, there is time spent in the drilling process as to which we are putting forces on that pipe, friction force along the surface, but then also friction force inside that first bit of curvature in the borehole. And then when we're starting to come up in that second bit of curvature in the borehole, and then during pipe bursting, we're looking at friction forces within that temporary soil cavity as we go through as well. So that's why general practice for us at DR17 is primarily used. We are looking at electrofusion or butt fusion in the excavations. Very routine to be able to do these types of fusions in the excavation. Lots of proven history that way as well. So inflow and infiltration, if you haven't heard that term before, you probably should start to Google CMOM, SSO, all sorts of things that the EPA has put out in governing documents and structure that way. SSOs, some within capital improvement or capital project development that are trying to get something new passed to be able to proactively replace infrastructure if the city manager or other people that determine budgeting aren't happy about the investment in income. Some of these CSOs or SSOs or other problems are some of the easiest way to start to implement your new capital improvement program, because now you'll have a consent decree as to which we have to go and actually mandate to do these things. So there's a difference between fixing that inflow and infiltration. Inflow, of course, is a direct connection between the storm event, and then infiltration then is an elevated groundwater table that seeps in through those joints of what you're seeing. Those are the primary differences, and I'll show you in the next slide how we're going to look at those in comparison to pump run times. So a pipe is often overlooked. Building a new wastewater treatment plant or water treatment plant, for lack of a better term on my part, is sexy to some engineers. And then essentially we'll go through and be able to build that treatment plant and plow a whole bunch of money in there, as opposed to fixing up that pipe nice and tight. So when we come through and do these rehabilitations, we really want to make sure that we get rid of that inflow and infiltration, because we're going to seal that system up and it won't lead to those SSOs. Again, they lead to that EPA consent decree. Here I put up a graphic for you. This is a pump station basin, gravity sewer basin in central Florida here. We had a fairly significant rainfall event. Tropical Storm Faye in 2008 had dumped 20 plus inches in 24-hour period on my municipality that I used to work with. That's a lot. So we had quite a massive rainfall event then. Quite a bit to deal with at the time, but when I look forward and try to apply some knowledge to studying the gravity sewer system itself, it gave me a fairly major weather event to be able to look to see if my system was sealed up tight or had inflow and infiltration. So when we start to take rain gauges and rain events, either historical or most of the water treatment plants, wastewater treatment plants also have rain gauges, we can start to compare those to pump station run times, which are stored in your SCADA system. And then you can have a fairly quick and easy method of being able to compare and contrast that inflow and infiltration that we're looking for. There are a lot more accurate, so to speak, ways of being able to do this, and there's also quite a bit of modeling that's out there if your agency has the budget or the capacity to be able to do it. I wanted to show something quick and easy to potentially get people thinking about rainfall events as we go through. So now we'll move to pipe bursting. So pipe bursting is a trenchless technology method. It's the only rehabilitation method that can put together a larger OD than the actual pipe that's there itself. This and cured in place pipelining are the two most popular for rehabilitation of gravity sewer systems. It really is quite this simple. This is, of course, a blue stripe as you're looking at, but the process is the same. This happens to be a static bursting process on a cast iron pipe as we go through. Gravity sewer pipe bursting can use both static and pneumatic. But when we're looking at pneumatic pipe bursting, high density polyethylene is the only pipe material type that you could possibly use for that. So it is less trench, as Pete had mentioned before. It's not completely void of excavation, but when we are looking at gravity sewer pipe bursting on main lines, we're looking at potentially even less excavation with reversible pneumatic tools and other things of that nature. So we get to pneumatic. The difference between static and pneumatic now becomes the delivery of the force. So the mechanism and the way to deliver that force. In static, we had a bursting machine inside an excavation. It pushes that against rods. In pneumatic pipe bursting, we are having a constant tension winch that's held up against either an excavation or a manhole as we go through. And then that keeps a pneumatic impact hammer aligned with the face of the pipe. So when we have that aligned with the face of the pipe and it's inching along as it goes through there, that has now an expander head that stays focused on bursting just that section of pipe where it is, and it inches along through the process. Significantly less force in a pneumatic pipe bursting process than static, because we're transmitting it just a little bit at a time, and it's driven by an air compressor above ground to be able to do it. Pneumatic pipe bursting within this country is far more used than static pipe bursting. They're starting to achieve a little more balance as potable water main pipe bursting grows fairly significantly, and so do the size of the programs that we're seeing for pneumatic pipe bursting. So City of Houston is one of the #1 consumers of high density polyethylene, and they're at 80,000 linear feet a month that they're looking at. So I took the liberty of putting some cost up here for you. Of course, some of the market influence has to be whether or not there's established pipe bursting contractors in the area. If they have to mobilize in from a few states away, obviously they're having a higher burden of mobilization through that process, and then a higher cost in that manner. Subsequently, the size of the project also has an impact on whether or not you're going to push out some of that mobilization cost to level it. Most engineers like to look at the per linear foot cost for rehabilitation. That's a good way to do it. I like to look at it as an out the door cost, where we're taking everything that's involved to execute the project and applying it in that manner. So obviously open cut and roadways is going to be more costly than open cut and easements. But one of the things I really wanted to put out and make people think about is the point repair. So a point repair is a portion of the gravity sewer system as to which it's collapsed, and we have to go through and actually excavate and cut that section out, put in new pipe, and then we can do a CIPP liner or something else through that pipe as we go through. If we get into the territory of having more than 1 or 2 point repairs on any length of manhole spacing, then we are getting into a situation that could be placing directly your CIPP lining price well above pipe bursting. Again, the way that the service connection, the lateral connections are made are different. In a CIPP lining, we are cutting that out from the inside and grouting it, or putting what's called a top hat or a lateral liner through that, and then lining further into the pipeline as well. So some things make it so that lining is not feasible. Collapsed joints like you see on the right, and then also you wouldn't think it, but sometimes the measured twice, cut once doesn't make it all the way to the crew. I've had some crews install liners that were short by 4 and 5 feet, and still continue to install it, even though as they saw it, obviously it was not long enough to do it. In that make the final connection to the manhole. In that situation, the only recourse that you actually have to either correct a failed liner or correct a short liner is to actually cut the whole thing out and replace the entirety of the pipe itself. So some things that have no impact on the cost of pipe bursting, if you can get that cable through the actual pipe, or you are going to be able to pipe burst it in many instances. So even though you see all this root debris on the left picture, in that situation, that cable can still make it through. That expander head, when it gets here, is going to forcibly push through this and still perform the pipe bursting project as they need to do it. And it's fairly routine, what you see on the right with even slipped joints in this, and soil intrusion is there as well. As part of any rehabilitation project, we do want to maintain service through that. So temporary bypass is oftentimes required. One of the key things in temporary bypass to think about is, as that project diameter and the flow increases, then the complexity of that temporary bypass continues to increase. And it makes it much more complicated to be able to go through that process. Richard, come on.
Hey, had a great question about the thinnest DRs for a bursting project such as sewer replacement. I know that the head takes most of the loads of the bursting process, Alan, but is there a percentage that load takes? Does it take all of it? Because what is the thinnest DR? I've seen DR17s go in without any problems. I think the longest run I've seen is about 350 feet from manhole to manhole. So I didn't see any problems with a DR17, but could we go thinner?
That's a great question. I am aware of thinner projects with DR ratings in the 22 area. Most times they wouldn't recommend a DR 32.5. With the DR 32.5 being as thin as it is, we are looking for an engineered backfill to go around that. And I'll talk here more a couple of minutes about open cut construction and how the pipe stiffness factor interacts with the soil stiffness factor as well, which plays into that DR 32.5 question. So the science behind how much force the expander head really impacts upon the pipe bursting effort. It's difficult to get equipment that measures that force to survive the burst through that process. And it has been done, it has been studied in a scientific format and more of a educational type approach, academic approach. But in most of those applications, they point to that expander head, which is really a hardened steel piece that takes most of that beating as they go through. However, there's not much more than anecdotal evidence at this point in time. That's why most of the industry has stayed with that DR17 as we go through. So unique to pipe bursting, sometimes municipalities will give a door hanger to say simply don't use your gravity sewer system or your house system while we're coming through. And then in some instances, you can use as simple as a lateral plug while they're working on that pipe as it goes through. Pete, you've seen some of that in some of the pipe bursting projects you've seen, right?
Yeah, those, Hammerhead makes some good gear for that. I continue to be amazed by those machines, but they are dumb machines. You can't direct them. It's not like a horizontal drilling or HDD head. I also wanted to add a little color to your question about that Richard brought up, Alan, as it relates to pipe bursting and what we see. Do we damage the pipe during installation? Is kind of the question that the individual was asking. And honestly, Alan, we don't really see much damage to the pipe. And I think it is because we're conservative. We use a lot of DR11, we use a lot of DR17, and we're not really pushing the limits by going to a much thinner wall. And remember, for the newer people in the audience, the bigger the DR number, the thinner the wall. So it's less capable from a pressure classification, as well as how much stress you can put on it during installation. The kind of issues that we do see, Alan, during installation with pipe bursting would be breaking of the tracer wire. We do see on occasion gouging of pipe if the soils are particularly bad, and we have rules for that. But honestly, we don't hear about pipe strings being damaged from pipe bursting very often at all. Polyethylene is a very robust material. The experienced contractors know how to use it. They know what the soils are like, and they plan accordingly.
Great, Pete, thanks. We had a good question from Jason LeMay as well, asking whether or not the CIPP collapse that we showed was a class 3 structural liner or class 2 liner. Most gravity sewers do not have to use a structural liner in that component. There's been advances in the past several years, but probably decade, thereabouts of class 4 structural liners for potable water applications that we are aware of. Whoever installs your liner got to make sure, just like we would with fusion technicians and people to study how to use Hdpe, right, that they fully understand how to install that liner in any application there as well. So in that particular photo, it's likely a non-structural class liner for gravity sewer applications. So here's some more information about temporary bypass systems, just a couple of pictures. In many instances, contractors can get pretty creative, but we also still need to look for entrapped air, what you'll see in the air release valve on the left side of the screen there as well. So even your bypass system itself can shut down if not properly treating the air. I wanted to show this picture to further elaborate on the size of that size of the temporary bypass as we continue to go. Now this was all set up for a 78-inch pre-stressed concrete cylinder pipe using cured in place pipe liner. The actual project itself required 45,000 linear feet of 24-inch to run. So this is a combined sewer itself. So this temporary bypass design had to account for potential rainfall events. Not only that, but the diurnal flow pattern, which we know is people actually using the regular gravity sewer system as they go to work or prepare to leave to go to work in the morning, and then in the evening they come back. They needed to understand what those flow rates were, and then also the combined weather pattern as we went through. So just show you a little bit more that, yeah, even though this is a large program, large project, a lot of things can happen specifically with HDPE to continue to make it happen through it. I did have a video, but we're running a little bit behind here, so I'm going to continue through. For pipe bursting, that connection to the manhole is important to us. We are temporarily going to enlarge the opening within that manhole to be able to accept the expander as it goes through. Then we will use some type of connection. In most instances, they'll grout around the high density polyethylene because while we are pipe bursting, we're stretching that pipe. We want to over pull into the actual manhole itself to be able to allow a 24-hour relaxation period where that high density polyethylene will return to its normal shape. We want contractors to understand that process does happen, so that way you don't cut it off right at the manhole and the next morning your pipe is moved through and you no longer have pipe within the manhole itself. So in seismic areas, the only option that we really have becomes now a high-density polyethylene manhole and high-density polyethylene connections through that as we go through and butt fusion through it. Lateral connections, we can also use a lateral pipe bursting unit that's going to be displayed here on the right-hand side, but what you'll see in the photograph in the middle now, they're allowing the pipe bursting process to go through and happen, and then they'll make that final connection. So the smaller the pipe, the more options we have for butt fusion, electron fusion fittings. And again, it's very common to be able to use these fittings for that connection. In open cut construction, what we're really looking at is a combination of pipe stiffness and soil stiffness on the denominator, and then the weight loading on the pipe, that's the numerator. And I'll show you that equation in the next slide itself. But if you design anything within the design window that you see here, 7 to 21 DR, H20 loading maximum of 3 feet or minimum of 3 feet, non-H20 loading 2 feet, maximum depth of cover 25 feet, you are okay. And I showed this video because Pete's put it on social media and gotten eaten up about it. But there's absolutely nothing wrong with being able to take advantage of not having anyone in the excavation to have a safe excavation and simply digging it out, making sure you had a proper foundation, and then embedment on top of the pipe with compaction as we go through. So that is a good way to be able to set up your pipe. Some of the things that are unique to high density polyethylene as we go through, as we put it under load, the pipe itself will move, which is called creep through it. And then when we take away that load, the pipe will relax, and essentially it interacts with the soil structure as we move through this. If there was no soil surrounding that pipe, then we would have constant creep as we have a loading on it. Now, when we put that soil through the pipe here, it interacts to become a soil pipe unit, in which case we do not have that missed ovalization or ovality of the pipe, and we balance that stress as we go through. So this is a good example of a pipe installation up in Richards Neck, the woods. Here, as we've installed this pipe, it did require force to be able to put it under that alignment. That force was did not deform the pipe beyond yield. Once that force was removed, then this pipeline does relax, conforms to its new shape, and then it'll further be protected from any other pipe stress on it by the soil that surrounds it. So the uniqueness of high density polyethylene is the fact that we can overcome and eliminate lots of other fittings in here, which would include additional friction loss as we move through. So this is essentially in AWWA's M55 manual, other guidance for you with PPI and studying how these equations work together, looking at the loading on top of this pipe. So this is a live loading, an earth loading, and a surcharge loading. It's divided by pipe stiffness factor, and then it's also a soil stiffness factor. As we get to a thicker wall pipe, the DR 7.3, we're looking at 1600 PSI for the overall pipe stiffness factor as we go through this. And again, if we get into a DR 32.5, we are quite a bit lower pipe stiffness factor. And that's when it plays into being able to come back through and compact the soil. So when we would come back with an engineered backfill, just compaction of that soil itself does a huge thing going from uncompacted to compacted here. And that's the second term in this denominator as well that further divides these loadings. So the loading that's actually on top of the pipe when we get down to an 8 foot of depth, and just by memory, I'll tell you an H20 loading only imbues about 0.9 or 1 PSI on top of that pipe at a 8 foot depth. So it's fairly significantly different what we're looking at. And when we do combine both the pipe stiffness factor and then also a properly engineered backfill as we go through. We look at trench width requirements. So in the 3 to 24 inch range, we're looking at the OD of the pipe plus 12 inches. Most buckets on the excavators are going to be about that size and easily interchangeable when we start to get up into larger sizes as we go through. And then here, unique aspect to discuss briefly on high density polyethylene is that it does not transmit an electric signal. So it does need either tracer wire or float balls or a function of both to be able to identify that pipeline as you need to do a utility designate in the future. Embedment requirements. So this is the actual particle size that can surround the pipe. In the 6 to 8 inch range, we're looking at the 3/4 a particle size. And the reason why I call that one out in particular is oftentimes that 3/4 inch size is referred to as a 57 stone and used to be a stabilization for the bottom of that trench, what you're seeing here in this picture. So that's very common in the industry and does not impact a 6 inch or greater pipe as it goes through there as well. So you can embed, you can dig these and install these just like you do your PVC or your ductile iron pipe as you go through there as well. So we get to force mains. We talked a little bit about horizontal directional drill. A unique thing to note is you do not maintain gravity sewer slope requirements typically with horizontal directional drill. So these are going to be force mains and other pipe of that nature. And that's just a control feature of how we directionalize this pipe. It is getting bigger and bigger. What you're seeing in this picture is a 54 inch pipe that was about 4,500 linear feet long, if memory serves correctly, in South Beach, and they had no issues installing this pipe to replace a failing pre-stressed concrete cylinder pipe, and did so very successfully as they went through. Richard, please.
Yeah, just to note, it was so successful, they have got a second project to continue that line as well.
Awesome. Stay on, Richard. You're going to speak to the next one too as well. So,
okay.
I think you took the video that we got on the right. So tell us a little bit about this one here.
Yeah, I did. This was in Miami, just a little bit, I guess, east of the airport, about a block and a half away from the highway. This is several sections of 54 inch that was being actually pulled in. It was a liner application or a slip liner application where the hose pipe was an iron pipe, steel pipe, but it was in pretty good shape. So they decided to line it just to protect it and give it some longer service life. The beautiful thing about it was you can see the hole is acting like it's pulling, but this pipe is actually being pushed from the back end. So I said, just undo the strap at the hole and let's push it all in, making sure that the host pipe didn't have any elevation changes where it could get hung up. So they said, no, they reassured me that it was really flat and in really good shape. So they just pushed it in. We pushed literally 350 feet in about 2.5 minutes.
Once the ID is all properly prepped, very little to stop you there. So we're seeing much more development of projects to line large diameter pre-stressed concrete cylinder pipe and other pipes that are failing with either this slip lining technology or what you see in the next one, which is a compressive fit technology. So here, the setup is going to be very similar as the slip lining technology that we look. So we want to prep the internal part of that pipe, make sure it's cleaned. If it's tuberculated, we want to heavily scrape out all that tuberculation, put a pig through that pipe that's a proving pig to be able to make sure that we've got the right ID through it and we don't have any changes in ID that may impact it. Now, what's different about a compressive fit lining project versus a slip lining project now is we are forcibly reducing the OD of the replacement pipe while pulling it through a smaller ID existing pipeline, and then we will allow that pipe to relax, regain its shape. So it is forcibly pressing up against that existing pipeline, in many instances interacting with it to where it's going to be even stronger from a pipe wall standpoint. And the finished product has no annular space to grout. It's important to note in these projects that anytime we have a connection, air release valve, other large diameter valve, we do need to fully remove that existing pipeline to be able to allow us access to work with it. Typically, they will fuse through electrofusion, butt fusion in the excavation to a MJ adapter if we're underneath that 36 inches to be able to push up against the valve and go from there. Richard's got a little bit more color for you. So
yeah, so just in this process, you can see the reduction in the size right at the die there, but you do have to remove the external bead, otherwise it will tear off and plug up that die flow system. But it is an amazing process, but in this also, this pipe was standalone. So the insertion pipe was also a standalone high density. So if the corrosion continued on the outside of that cast line or that steel line and eventually went away, you wouldn't have to replace it because the DR was designed to be standalone by itself.
Good. Another important distinction here is there can be very significant forces pushed up against that die as we're pulling that pipe through. So we'll need some type of a soil interface restraint that'll stop that and die header from moving through that. So they may pour a dead man, something similar to that. Same thing happens in pipe bursting. They'll often put I-beams into the ground to stop the advance of a machine in a static pipe bursting operation. And in pneumatic pipe bursting, the forces aren't anywhere near as large because, again, we're just inching along in that pipe as we go through that. So those are things that most of the contractors out there that are experienced know, and then they properly plan for. So we're just trying to share as much in a small amount of time with you as possible. So manholes are necessary for that access for cleaning, inspecting those main lines, facilitate those changes in direction. We don't want to change in direction in gravity sewer systems unless we're able to get in there and clean out. Again, what I mentioned before about seismic resistant systems, the only option, and I've been asked this question multiple times, what we can come up with is fusion across that entire interface. And there are lots of options through manholes that are high density polyethylene that allow you to butt fuse at the connection, electrofuse at the connection, or do other types of fusion as we go through this as well. So all new manholes that are are brought to your either brand new job, gravity sewer job, or your rehabilitation project, typically, no matter what the material type, they are going to be fabricated off site, unless your preference is to rebuild a brick manhole in that specific instance. So what we are doing in the design phase is to make sure that we have all of the key things that make the flow through that manhole still continue to flow in the design system in the right invert elevations, the right angles, and the right area itself. A benefit of high density polyethylene over concrete, precast concrete in these scenarios is it's a little bit easier to work with to cut out that angle or the invert for high density polyethylene. Excuse me, in some instances in the concrete through as we go through. So you can get a fabricated manhole for you, as you see many here in some areas, which we're seeing here in Brunswick, BJWSC. The name is going to come back to me here in a few minutes. But in the left side picture, maybe Pete can help me out. This is in a coastal Georgia environment, and they were dealing with a fairly significant amount of corrosion in their system itself that was eating their concrete manholes away. Beaufort Jasper. And so they specifically set out to install high density polyethylene manholes, and have very successfully installed those to be able to resist that corrosion from the constant flow of salty seawater in the bayous in their areas as well. So in the middle picture here, what we're seeing is starting preparation of a brick manhole for pipe bursting. As we'll go through, you'll see just how Brunswick, Glenn County Joint Water. Thank you very much. And then you'll see as that goes through how short those VCP joints are as we go through. And you'll also see the precast concrete manhole on the right as we go look at how you're going to be delivered new products. So a connection to the main lines is we're looking at laterals. So laterals can be still a major source of inflow. In infiltration, as we're looking, we want to make sure that that lateral is in still in good condition. Any breaks within that, including a broken clean out or something like that, can be a major source of sand intrusion. I often asked the cleaning and TV operator to report sand almost immediately, so that way we know that there's major breaks within the gravity sewer we probably need to address sooner instead of later. In some instances, by the time that you CCTV a project to getting it through the municipal system to bidding, you could lose as much as a year between that process, and some instances more, depends on the efficiency of your municipality. The site conditions can change fairly quickly, and that's why they oftentimes include CCTV pre and post for your contractor to validate site conditions. Pete.
Hey, Alan, I'm learning a ton and I love this deck. I just wanted to let our audience know that this is a planned 75-minute session, and we're going to run right up against that 15 minutes after the hour. Alan's got a lot of great slides left. I just want to give everybody fair warning. A lot of great content to come. We'll be done within the next 20 minutes.
Okay, so very little stops those root intrusions. That tree is going to find what it's looking for. Those roots are going to go after it. So having the benefit of a leak-free, a joint-free system without that balance spigot, without the gasket, we're now going to permanently stop those from being, those roots from intruding into that gravity sewer pipeline and taking over for us. In some instances, we may find ourselves up against low lateral locations. And in pipe bursting, when we take the theoretical spring line, which is the center of the pipe, and we increase the size of the pipe, now that theoretical spring line is higher. So before, if you had a lateral that came in at a low location and it had very little slope on the lateral, you couldn't easily just put it up to the center, the spring line of the pipe there. So this Faction Fusion is accompanied by a pipe bursting contractor in California that came along for this problem and then found and invented this low rider saddle to be able to adjust that, as well as a new way to do fusion under vacuum that they do fairly easily. So this is another option for you in making those lateral connections all together with fusion itself. So force main valves, if we're looking at valves, there's, of course, as we get larger in that pipe, your valve options are going to increase as well. And so it's not uncommon to be able to connect with flanges if we get above that 16, 24-inch size. What you're seeing here on the right is an MJ adapter, and it basically is extruded with a heavily reinforced lip that you're seeing on the outside, and then it has a flange plate that is a backup against it, so it will attach directly to your valve. Very stout belt and suspenders connection itself that is considered to be a fully restrained connection. They do make these up to 36 inches. Whatever your preference of valve that you want to put into your force main for control and everything, that way you are more than welcome to do it, and do it with high density polyethylene, either flange adapters, MJ adapters, or the like. They're also putting and making AVK is making a high density polyethylene pushed on lip that you're seeing here. So they are able to make a fully metallic valve with the lips of that, and then they're forcibly pushing that polyethylene. Please remember that polyethylene does want to come back to its original shape, but it's going to transform and then hold on like you wouldn't believe on this valve. So they have done many internal tests that come through and try to pull that piece off, and they're not able to do it. So here's a cut sheet for that valve, so you could see the internal workings of it. Very stout, proven valve for us in that scenario as well. For smaller diameter pipes, we do have smaller diameter valves. These, I believe, are up in the 6-inch and 8-inch range as we go through. And these are all polyethylene with some polypropylene conditions. And the industry itself is starting to look towards full air release valves as we go through as well, through some encouragement. So that's something else that you can do out there in webinar land. If you have a specific need for a specific project or application, definitely voice up. And the industry does a whole lot of stuff very specific to some of the things that you need. They can field fabricate quite a bit for you. Force mains, as we connect multiple pipes from multiple submersible pumps at pump stations, they need to be able to have minimize friction loss as much as possible through getting to that common force main as we push through. So we'll see some of these Ys and bends and other fittings to be able to come out and make that connection for you as well. So lots of things that they can do. In the fabrication field, they've been working with industry for their specific needs for some time, and that's going to be industrial applications. That's going to be other things of that nature. So this is some actual pipe from that Fort Lauderdale job that we had discussed before as well. They had very specific needs on direction for this larger diameter to be able to make connections, and then came through as well to install them in the field as that project moved along. So there's a lot of different ways to be able to put all this together. Similar to how we're looking at manholes, when we have very specific pipe layouts, a lot of that's going to have to be designed in advance of just putting it in the ground right there. So if we know what utility conflicts we're going around, or what our profile grade needs to be in order to be able to install in congested areas, then we are going to put a lot of forethought into designing what actual pipe we're putting into place. I wanted to show this photo of a pipe display, even though it maintains a fair amount of potable water, blue stripe pipe in it. And that my visual of this pipe display as the Alliance folks have put it together and then re-put it together over the years just continues to increase just how many options there really are for you out there. So if you're looking for that entire wet well to be made out of high density polyethylene, we can do it. If you're looking for manholes, which you'll see here, that was custom fabricated in order to be able to put it in the ground with the appropriate entrance angles and invert elevations, and still forming that channel at the bottom of the manhole and the bench to make sure everything slopes to that channel, you could still do it. And there's nothing that stops you from using high density polyethylene and harnessing all of its corrosion resistance as we go through. So here's just a couple of more fittings from the potable water land that can be manipulated as well. So when we look at the strength of fusion, I want to back up to open cut and what pressures were really being put on the external of that pipe. Remember, at 8-foot burial depth and H20 loading only had an effect of 1 psi on the pipe. By the time that we electrofuse a fitting to a pipe and do it the right way, if that pipe internal pressure is resistant to 200 psi, it's not going to care what's on the outside of that pipe. It's just going to be stout. It is designed and constructed very specifically to be a stout pipe, and is not going to care. Let's move into maintenance and operation as we go through. So we do have to flush and jet and clean that oil and grease buildup as we go through. Again, any sumps that may be in your pipeline as you move through, that's going to be a spot as to which we're going to have grease buildup. Any operators out there, you typically have areas within your system that you are aware that have grease buildup that we're pushing through. Hopefully you'll get an oil and grease separator if there's a restaurant or what have you. You can frequently cut those roots out from mechanical meshes as we go through. Smoke testing and CCTV. Hopefully if you've got a pretty robust program for CCTV to know where your problem areas are, and if not, that probably should be a priority as well. I wanted to show this cleaning video for you. This one gets a fair amount of laughs when it's been abbreviated here. It should be a little bit longer than that. Essentially, Pete was asked by San Francisco Public Works to be able to show what 5,000 psi pressure water did to high density polyethylene. It does nothing. He put his GoPro inside this pipeline, and we came through at 5,000 psi. Eventually, he lost his GoPro, but they inspected that pipe fully, and it did absolutely nothing to the inside of that pipe as well. So most cleaning and TVing throughout the country, they use the cleaner and the high pressure hose flushing first, and then they come through and do that inspection as we go along. So CCTV here, I showed you this video at the beginning as well. So that white pigment or gray pipe is going to reflect that light better as we go and put that CCTV camera through the pipe. You can still continue to see the integrity of the pipe, and you'll see a long-term life of no root intrusion and no other issues. Richard, yes.
Yeah, just as another side note, high density doesn't support any biological growth, so there's nothing for any organisms to feed on, and nothing really adheres to it. So the cleaning becomes very easy. So over long periods of time, if you do get buildup of greases and things like that, they're not difficult to remove because it just doesn't adhere into the surfaces.
All right, good. Again, with pump stations, this is starting to develop more so here. Pump stations are a major source of corrosion and have lots of failure components that need to be replaced on different schedules through that as well. So one of the most common failure components happens to be above ground in stainless steel controls. So this is going to be the areas to which we have SCADA in the intelligent portion of the pump station operations, where you'll program when the pumps come on or off based on floats that measure obviously the wastewater discharge within the pump station itself. There's been some movement towards having the suction pipes that come off of the submersible pumps and the impellers through there to be high density polyethylene, just because of all the corrosion that happens to be within that pipe system. And then those impellers, of course, become a wear item as we go through as well. So if you are in responsible charge of maintaining pump systems and pump stations out there, please talk to your operator, or if you're the operator, make sure that you understand that the wear components help that system run even better. And design engineers out there, even sometimes the way as to which your discharge pipe falls onto the submersible pump makes a difference. There's lots of debris and other entrapped hair and other things that way that can get stuck on top of the submersible pump that then becomes a maintenance item that has to be, that pump has to be raised and that debris forcibly removed via cutting off of the actual submersible pump as well. We of course do not want pump failure, and we do not want pump failure on Christmas Eve, the night before itself. So that's the time that's to which you have to roll out there and mobilize to remove your pumps, clean off anything that may have been contaminated, and figure out troubleshoot what's going on with the system and continue to go from there. Those force mains, they're pressure rated, but they don't always flow full in that manner. Corrosive gases can be released when these start to dump into a wet well or a manhole. If it's a smaller diameter, pressure surge when the pump comes on, and sometimes we look at the vacuum pressure within the pipeline itself. Richard, do you want to come along and talk about Hdpe and its surge pressure allowance for us?
Yeah, sure. So in comparing high density polyethylene to PVC and ductile iron products that are currently being used, as you can see in this demonstration, high density has a multiplier for reoccurring surges in a pressure class of 1.5 times that pressure class. So in the pressure class for a DR11, for example, then it's 1.5 times to 350 psi. And this is for millions of cycles that your system would operate. And this was really designed more for water systems, whereas because they're under pressure constantly, whereas in sewer systems, this is not really applicable, but it gives you still that added strength. Occasional is defined as an unscheduled event of surge, such as a power outage or an emergency pump start or something like that. And it's really important to understand this because of our ductility that we have in high density polyethylene to actually absorb the energy that is caused by these surge events. So they're not really a concern to us because we will last for years and years, over 100 years with these surge events occurring. And in our water systems, the average across the US is about 53 cycles a day. And if you multiply that by 365 days and 100 years, you're going to see you're not even going to get close to that 10 million cycles that we've tested at. So it's really a huge built-in safety factor for these piping systems.
And all you conservative engineers out there, that's what we love. We love that belt and suspenders, conservative safety. We often get questioned and asked about internal bead removal. It is not necessary. The Manning's N, or the friction coefficient within this pipeline, is assessed with that internal bead. We do see in some instances in very low slope conditions Some conservative engineers are concerned about things building up on the bead as it goes through. So you can remove that internal bead. And here's two animated GIFs showing you how to do it. You cannot do it after it's been installed, so it has to be done first. It can be a pretty easy process to go through to remove that bead. For large pipe, for long lengths of pipe, sometimes this does put a separate burden on us that if you do not have the very low slope condition, that you won't have this. Something else to consider in your low slope condition is if we do not have movement of that material through that pipe, sometimes it can turn into an anaerobic condition, in which case we can start to create a lot more of hydrogen sulfide. And for anyone out there that knows about gravity sewer systems and have seen the direct effects of hydrogen sulfide, this is what we're looking at. In many instances, that concrete mixture is going to be just completely eaten away very, very quickly, and it's going to encourage that corrosion. So we really want to look at low slope conditions and then how to eliminate that hydrogen sulfide or other gaseous entrapment, and proper placement of that air release valve is something that we're really looking for. So I only got about a minute left. We have one slide on repair options next, but before I move on to that, we want to make sure that the profile point as to which we are aligning this air release valve happens to be the high point, and then we are effective in maintaining those air release valves in their location as we go through. So you do want a program to be able to check to make sure that that air release valve itself has not been corroded to where it's inoperative or not doing what it needs to be doing. One of the other things that could happen with entrapped air within your pipeline is if it's a large enough air pocket, you could denigrate the amount of flow that goes through that pipeline. In some instances, even include the entire pipe ID if we're not handling that correctly. So contractually, you would try to identify where the profile, the high point was in the design, but then also have mechanisms on the tail end to be able to have the contractor validate where that is through the as-built process. So if we did have to repair this, there are repair options, but you can certainly use electrofusion, butt fusion of spool pieces as we go through, and lots of other fittings for those. As to which butt fusion is the preferred. You can even butt fuse a large diameter pipe in the excavation. Every machine that has been designed by McElroy is designed to do this very activity for you, as you see, and then come through. And here's just some examples of electrofusion of a spool piece itself. So I'm going to breeze through resources, have Richard, Pete, and Dan come back on so you could see us again. I still don't have a tan. I wish I'd be out there getting that tan over the summer, but we spent most of the time here prepping up new material in different ways to show it to you. And also, the second half of this year is also going to be very, very, very busy. So if you like what you see, there's lots more of it. And Richard wasn't set to talk on this one, but we can't get him to stop talking about HDPE, and that's not a bad thing. So please, guys, if you got something else to say, let us all know.
All right, Alan, great job today. Thank you so much. And Dan, is there a survey that people can fill out and tell us how we did today and things they'd like to see in the future?
Yeah, there is. A survey question today is, do you guys have any projects you're working on? If you have any information you need. We covered a lot today. There were a lot of questions. So the survey is a chance to share any projects and any help you guys might need. We can take a look at it. Whatever you guys need, let us know. But additionally, if you have any requests for any sort of resources, particularly those on the page right now and or PDH, if you leave a comment there, it'll save you from emailing us, but go ahead and shoot me an email, any information you guys have, and we'll do whatever we can to help.
Yeah, and we just got a question if this presentation is available to the listeners today.
Yeah, good point, Richard. Yeah, it'll be available tonight, sometime probably after 7 or 8 o'clock on our YouTube page, and that is Alliance for PE Pipe on YouTube.
Oh, and Dan, how do people get a PDH for attending today?
They can either leave a note on the exit survey or send me an email, and our colleague Michelle Fitzgerald will get that emailed over to you within a week or so.
Awesome. Hey, Alan, great job today. Thank you, Dan Landy. Thank you, Richard Colassa. And we'll see you soon on the PVC versus polyethylene webinar coming up in a couple short weeks.
Thanks, everybody.
Thank you.